So I've loaded the data, and I can look here at the 29 columns. And unlike the hospital readmissions project, they don't have a list of tasks. So the tasks are basically contained in the project statement and in this RMD file. They give us some code chunks. They tell you how to construct a box plot. And they give you some code in order to convert factor levels to those which have the most categories. And they call the dataset full.ds, which in my opinion is a terrible name because it takes so long to type and it requires capitalization. So I'm going to press Control F and then copy and replace this with just df, which I think of as data frame, which is just very easy to type because the D and F are right next to each other on the keyboard. So now I don't actually read the data because it's already in the R library. So I'm just going to call that student success. And then I can see that there are 585 observations. And this is showing you the values of D3. I like to use count. I have to load the tidyverse library, which will be on the Prometric computer. So I want to count the G3 column. Okay, you can see that there are some negative values, and if you look in the project statement, G3 is the grade of the final trimester. There are 4 variables observed, okay? The grades are on a scale of 0 to 20, but we may want to model just the pass rates. If you can figure out a way to build a model for whether someone will pass instead of the overall grade. So there are 3 students that have a grade of less than 0. So I removed 3 students who had grades in the final trimester that were less than 0. And I like to start off just by summarizing the data overall. There were 29 predictor variables and 585 observations of students. I'm not going to worry about fixing spelling because I could do this at the end. I'm just going to use the word review grammar and spelling at the very end. So these are related to student demographics and lifestyle. The target variable is whether or not a student passes their final trimester by achieving a grade of at least 10. And let's just look at the other grade values to see if they're always positive. Yes. G1 and G2 were always 0 or greater. And then they create G3 pass flag. I don't like to use uppercase letters in my column names because it takes longer to type. Better yet, I'm just going to call this pass. And then they remove these other variables. Another way of removing variables is to use select and then minus the variable name. So if I want to unselect pass, you just use that. Data exploration and cleaning. So I suppose technically you should do all of the exploration and filtering in this RMD section because the grader will expect you to. So I wanted to filter G3 is greater than or equal to 0. And if I look here, I'll see that there are 585, and then there are 582 afterwards. You can look at a summary, and there are 29 predictor variables. It would take me a long time to go through each and every one of them. I believe that's why they gave these questions here, so that you only need to answer the questions that they ask you. The first question we have already answered. The second question, we want to use 29 predictive variables in order to advance, in order to model G3 because we know them before the school year starts. But in the data set we have includes G1, G2, and absences. They have been removed in the RMD file provided. Okay. So in other words, because our goal is to help educators identify which students will pass at the beginning of the year, we only use variables which they would know in advance. We do not include the G1, G2, or school failures would not be known. Other variables. School is fine, sex is fine, age is fine, address, family size, parent status, education status, reason to choose school, guardian, travel time, study time. One could argue that these would not be known in advance because they could change throughout the year. Failures. So we don't know failures of the current school year until the end of the school year. Internet, romance, these other variables, except for absences, and absences would not be known in advance. Okay, I'm just going to go back and read again. Okay. So we have completed tasks 1 and tasks 2. Let's go back and actually remove them. So say df is equal to df and select minus absences, failures, and I cannot spell absences. They've already removed absences. So it seems. Yes, they already removed absences. Okay. Even if they're the ones who do something, like they are the ones who remove G2 and they removed G1, I still say that I did that because technically it's part of the analysis that I did. Okay. Okay, so the next question is, this is a good time to decide if records with unusual G3 values should be removed. Okay, I've already done that. But because they asked me to put it right here in the RMD file, I'm going to put it right there. It appears that there are some outliers. I've used my box plot function to look at age versus passing. Possibly should be done for other numeric variables. Okay. Let's look again at the values. Age goes from 15 to 22. That's reasonable. What is the age of these students? So School Whiz is a group dedicated to providing remedial education to troubled students. These are high school students, right? It just says there are 29 predictive variables collected prior to the student entering the formal school year. So it's not really clear. We notice that the ages go from 15 through 22. Some of these students are probably too old to be included with the other students use search Control F for age. Okay, they say age is a student's age from 15 to 22. And it does. The data dictionary says that it goes from 15 to 22. They don't give us any other information about the age. This matches the description in the data dictionary. Address, family size. Family size is, so if I have these character variables and I want to see the counts, I can use mutate. Mutate if is character as factor. And then I can actually do select if. I can just select the characters. And then summary is factor, I suppose. Here we can see all of the levels for the factor variables. I'm using Control left bracket in order to adjust the font size. And let's do this for the numeric variables. Select if is numeric. Right. So I'll just create some bullet points. All students came from one of two schools. What is address? It's either R or U. No, I believe, so what does address stand for? Address is student's home address, urban or rural. And an urban or rural address, family size. So GT3 is greater than or equal to 3. Add families of at least 3. Say most had. What is P status? Parent status. Apart or together. Most had parents that were together. The most common job was services. Was actually other. And most common father's job was also other. What does other stand for? They don't tell us. What is reason? Reason is the reason to choose the school. Most have a mother as their guardian. School support. Most do not have school support. As only 58 students have support. And what is school support? It is extra educational support. Family support. Most paid. What is paid? Paid is extra paid classes. Activities. About half of the students participate in after school activities or extra activities. Nursery is attended nursery school. All right, this is taking me a long time. Higher is wants to take higher education. 559 students said that they wanted to take higher education. I'm assuming that's at least college. This would imply that these are high school students. Internet, 98 students do not have internet at home. I find that difficult to believe. What year was this data collected in? This is difficult to believe. Romantic has a romantic relationship. 225 do not. So about half. What is pass? Pass is... Oh, so pass is the target. That's the flag. So 200 students. 201 students passed with a grade in there with a G3 of at least 10, and 381 failed. That seems very high. That seems very high. Let's check. Yeah, that's what it says. So that's a pass rate of 201 over. That's a pass rate of only 35%. 35%. Right, half of students are in a relationship. 34% pass. The average age is 16. MEDU. MEDU is the mother's education from 0 to 4. Okay, so average mothers and fathers education level was 2.85, 84, 5, 2.9, and 2.7. So their mothers are on average more educated than their fathers. Travel time is on average 1.4. Now it's interesting that these are numeric values when they're really referring to minutes. So it's 1 to 15 minutes, 15 to 30 minutes, 30 minutes to 1 hour. So they are in order. And that means that they could be used in a model either as a numeric value or as a factor. If they were out of order, like if let's say 1 referred to 1 hour to 2 hours, and then 2 referred to 1 hour to 15 minutes, or 15 minutes to 1 hour, then they could not be used as numeric. They would have to be used as a factor. But because they're in an increasing order, it will work to use them as a numeric value. Travel time is a numeric value where a higher increment value that is in buckets of 15 buckets of less than 15 minutes, 15 to 30 minutes, 30 minutes to 1 hour, 1 hour plus, which means that we can use the numeric levels from 1 to 4 directly in the model. The mean travel time was 1.841, which doesn't have a clear interpretation. But that's okay. It's just a numeric value. Similarly, study time was a numeric value with a mean of 2. Go out. Go out with friends. 1 is very low. 5 is very high. So is it better in this case to look at these from a frequency perspective? If we want to do that, we can say df mutate at, well, no, I'll just say select, and then I'll select the variables that I want. So let's see. So let's say that I want to select travel time, study time, FamRel, free time, go out, delk, welk, health. So what I'm doing is just looking at all of the variables that have a numeric range, like travel time, study time, free time, and so forth. I select these, and then I want to mutate all as factor, and then run a summary. I don't think they expect you to be able to do this. However, if you do get a question like this, it cannot hurt. Because some of these variables were numeric with a range where a higher value indicates more of something, such as more time traveling or more alcohol consumed, I converted them as two factors to look at the frequency of each level. I noticed that most students travel less than 15 minutes, study, where's studies time? Study 1 to 2 hours per week, or per day. It must be per day. What is family relations? Family relations, quality of family relationships. Very bad is 1. Have family relation of family relation. Status of 4 out of 5. Free time is, it doesn't say, it just says 1 is very low. Free time is 1 is very low. Have of 3 out of 5. Go out, whatever 3 out of 5 means. Go out with friends. 3 out of 5. I don't know how, see, the interpretation here is really vague. 3 out of 5. Maybe this means like 3 out of 5 days per week. I don't know. Delk is weekday alcohol consumption. 1 is very low, 5 is very high. So do not, weekday. Do not consume alcohol on the weekday. days often well consume alcohol most often on the weekends. Health status is mostly a 5. This is the current health status. Are in very good health. Okay. And it appears there's some outliers. I've used my box plot function to look at age versus passing. So these are the failures. And you can see that they have a higher age on average. So let's put this into the graph. It's hard to know what exactly they're looking for. And so I just include anything that I think they might want to see. Students who fail are older. Let's just look at the age. So let's get the average. Let's get the percent of let's get the average age by those who pass versus fail. And that is 16.9 versus 16.5. Okay. For categorical variables, which for this purpose could include those on 1 to 5 scale types, I find a way to make bar charts. Oh, great. We've already spent a lot of time doing this. Mother's education versus pass and failure. Oh, okay. We haven't looked at this graph yet. MEDU is odd. Would expect more passing with more mother's education. Not clear what 0 means. Can someone really have no education? No time to check with my bosses here. Few in this category. Only 3 have no education. So I'm just going to remove those. DF filter MEDU is greater than 0. I noticed that there were 3 students whose mother's education was listed as 0 because this did not make sense given the data. Because this did not make sense, I removed them. Let's look at the father's education. There were also 2 students with FEDU of 0, which I removed. So this says 4 categorical variables, which for this purpose could include those on 1 to 5 type scales. I found a way to make box plots. So they expect you to do this for the other categorical levels that are on the scales of 1 to 5, which is what we have already looked at here. But it's, again, it's if they give you something, it's always a good idea to show that you know how to use it. Like, let's look at weekend alcohol consumption. I'm just creating graphs so that I can put stuff in the report. That's basically it. Okay. Let's do this for, well, this is weekly. Let's also do this for daily. And this is weekday. Okay. I also looked at some bar graphs to examine, to see how the students, I also looked at some bar graphs. Here's an example that shows that students party on the weekends. Probably not actuarial students if they're in high school. Here's an example. Okay. What else do we have to do? What else? What else?